Now I am going to discuss about piezoelectric transducers. So these piezoelectric transducers will measure the pressure in terms of electrical quantity. That means pressure will be converted into, that is, non-electrical quantity is converted into electrical quantity. Now the construction diagram of this piezoelectric transducer will be like this. So this is a complete case. On this one, on the top of this case, you will be provided with a port on which this is the pressure port on which you can apply the pressure. And under that you will be having the summation member, and under that you will be having a Rochelli salt crystal. So whenever you apply pressure on this pressure port, what happens is that pressure will be applied on the crystal. So this Rochelli salt crystal will convert this pressure into electrical output, which we can get it across the output voltage terminals. And this is the base which is fixed. So as the pressure is in, how much pressure you are going to apply, that is proportional to the output voltage. So if you apply more pressure, then the crystal gets compressed and more output voltage will be getting. As soon as you remove the pressure from the pressure port, this Rochelli salt will go back to its original position. So this is how the non-electrical quantity pressure is converted into electrical output voltage. Okay, this is the piezoelectric transducer. Next one is the photovoltaic cell. So the name indicates photons means light. This light energy is converted into voltage, electrical quantity. So this is called photovoltaic cell. This photovoltaic cell is also known as a solar cell. So this solar cell, how it is going to convert means, see here, uh, this is the solar cell. This solar cell will be having a positive PN junction diode, that is a P semiconductor and negative semiconductor, positive semiconductor and negative semiconductor. In between these two conductors, you are having the PN junction formed, and from both the positive semiconductor and negative semiconductor you can get the output voltage here. So this is one of the photo detectors. It converts electromagnetic radiation into an electrical signal. The generated output voltage at the output of the cell is proportional to the intensity of the electromagnetic radiation. So how much light energy it is going to absorb is that much amount, that is proportional to the output voltage. If more light falls on the solar cell, then more output voltage you will be getting. So as soon as this light energy falls here, based on the electromagnetic radiation, the holes and the electrons get divided, and then there is a movement of these holes and electrons. The movement of electrons is nothing but the current, so that you can get the output voltage here. Yeah, this is the photovoltaic cell. Next one is the photoconductive cell. So photoconductive cell means based on the photons means light, based on the photons it gets conductive, it gets conducted. So that means this is the construction diagram of the photoconductive cell. See here you can observe this is the cell here. This is the ceramic base. On the ceramic base you will be placing a semiconductor material. On that, whenever light falls on that semiconductor material, this is a ceramic base will absorb the light energy, and this acts as a resistor. This acts as a resistor. So when more light falls, then more amount of resistance will be there. Because of that, more amount of current flows in the circuit. Less amount of resistance, because of that, more amount of current will be flowing. So the circuit symbol will be like this. This is the circuit symbol, on which these two lines indicates the light energy. When light energy falls on this surface, then what happens is current is induced in the circuit. And in general, it looks like this one. The shape of the photoconductive cell will be like this. So it will be having two electrodes, and on these are electrodes are pinned to the surface, and this one zigzag pattern, that is nothing but the cadmium sulfide. So this cadmium sulfide will attract the light energy. When light energy falls on this area, then it absorbs the light energy and current will be flowing through the circuit. The main applications of these photoconductive cells are these are used in the street lights. So during the daytime, the current will be absorbed and it is stored in the power source. And during the when night time, the absorbed current will be given back to the light so that it will you will be getting the output. So this is about the photoconductive cells and the uses of these photoconductive cells. These are used in street lights like that. Okay. Next topic is photodiodes. These photodiodes, in general, this is a diode which is having anode and cathode. When light falls on this anode, that is on this diode, this becomes a photodiode. That means when light falls on this diode, then what happens is it will be conducting in the reverse bias direction. So that means here for a diode, the real reverse bias characteristics will be like this. So this is the negative voltage and this is the negative current in terms of microamperes. So whenever in the reverse bias, the anode will be conducting states. So that means it becomes for some amount of voltage there is more amount of current produced. Whenever light falls on it, it becomes reverse bias and it will be conducting. So in the daytime, in the dark current means whenever there is no light, there is no amount of current flowing in the circuit. So only it is having small amount of voltage and small amount of current. This is the dark current. It indicates that there is no light falling on the diode. So photodiode means based on the light, it absorbs the light and it will act as conducting material. So if the diode is reverse biased, then this photodiode will act as a photoconductive cell also. So when the photodiode acts as in the reverse bias, then it acts as a photoconductive cell. So these are the different types of photodiodes based on the light energy. It is going to convert into the electrical signals. These are different transducers based on light energy. Okay.